Hey everybody, Mr. Covey here, and this is page 21 of your note packet. And we're just going to take some notes today, and I'll kind of do a couple of examples for you before you guys do some practice. Okay? So last class we talked about making histograms, and what we're going to talk about today is first, when you can look at the shape of a histogram. Okay? When I say the word shape, it actually has like a statistics meaning, but it's also just like literally like what shape is it? Okay? So when you make a histogram, there's a few different shapes that you'll see. I have pictures here of the different shapes. I want to talk about them real quick. The first one is bell-shaped. If you're like bell, it helps to kind of trace it like that, rather than just looking at the bars. And if you look at that, it kind of looks like a bell. Bell-shaped distributions of data are really common, and we're going to talk about those a lot on Friday. But they're really common. They're kind of like symmetrical, which we'll talk about. They're kind of even on both sides, and they're really common. Sometimes you see U-shaped. It's not as common, but it's basically kind of the reverse. Uniform just means it's kind of flat. Sometimes you'll get a histogram that kind of just looks flat. You'll also see bimodal data, and this word bimodal means that there's two modes. What it means by modes is, remember that mode is what shows up most frequently, so basically there's two peaks. And sometimes you look at a histogram, they'll kind of have two peaks. So all I want you to be able to do now is kind of like be familiar with these terms. You'll also hear about right-skewed and left-skewed data, and that means it's kind of sloping down to the right, or left-skewed is sloping down to the left. And then J-shaped is kind of similar. Just want to throw out some words there. So we'll be looking at histograms, and I might use some of these words or ask you to use some of these words, and I'd like you to kind of be a little familiar with them. Okay? One important idea is that if your distribution is skewed or J-shaped, these two, it looks like that, it's really uneven. Instead of being kind of like even, it's uneven. Okay? And when it's uneven, we're going to use the median. We can talk about that in a second why. But we're going to use the median to talk about what's the center of the data. If your distribution is symmetric, then we're going to use the mean to talk about what's at the center. So if you look at these green ones, they all look a little different, but the thing they all have in common is all of the green ones are symmetric. The red ones are not symmetric. For the red ones, we're going to use the median. For the green ones, we're going to use the mean. And I'll explain that why a little bit more later. Okay. All right, flip the page. Before we talk about that, let's just remind ourselves what mean and median are, okay? So remember that mean is a fancy word for average. Okay? And how do you find the average? You add everything up and divide by how many there are. You guys know that. It's the average. You add up and divide by how many? The mean, the average, is different than the median. The median, you might remember, is the one that's in the middle. Literally in the middle. When you line up all the data in order, it's the one that's in the middle. Okay? How do you find it? You order the data. The data has to be in order. And I usually just count in the middle. So when somebody asks you, hey, what's the center of this data? Like, what's in the center? What's in the middle? Well, what's in the center? When they ask you for what's in the center, there's two different ones you could use. You could find the mean or you could find the median, okay? The real difference between them is the median is resistant to outliers, and the mean is impacted by outliers, okay? This is an important distinction to make. So I'll give you a quick example. If you're trying to figure out the the center of a data set of test scores, and the test scores look like this: 76, 80, 84, 90, and 92. Sorry, get rid of the 92. Those are the test scores. You have somebody that got a 12%, and you include that 12%, it's going to change the average a lot. That's going to change the mean a lot, because that lower score, that outlier, is going to drag down the mean. That 12, that outlier, isn't going to change the median very much. It doesn't matter that it's way lower than the 76. It's only going to shift what's in the middle a little bit. In fact, if that 12, instead of being a 12, was a 70, it would have the same impact on what's in the literal middle. Okay? So it won't make that big of a difference, the fact that it's a 12, that somebody got a 12%, if you use median. It's resistant, it doesn't change a lot when you have an outlier, a point of data that's way far away from the other ones. The mean, on the other hand, if you found the average test score, it's going to be really low because that 12% is going to drag it down. So the mean, the average, can be dragged down by outliers or dragged up, but the median is more resistant to outliers. And we'll talk about that idea more, but it's kind of an interesting idea. So you have mean and median. There are these two different ways to talk about the center of the data. If we have a data set, the other thing they'll ask you to find a lot is something called the 5-number summary. And I'll do an example of this with you guys. But the 5-number summary is the median. That's the one that goes in the middle. The lowest number is called the minimum. So you're going to look at your data set, you're going to find the minimum, the median, and the maximum. And then in between the min and the median, there's another number called Q1. And in between the median and the max, there's another number called Q3. So together, these 5 things make up your 5-number summary. So you're going to be given a data set and asked to find the 5-number summary. Okay? I think it'd be helpful if we did a little. So flip in your notes to the page that says Notes from the Quizzes. And I'd like you to pause and write down this, please. So pause the video, take a second. I think this is on page 24. And write down that data set. Pause the video and do that, please. Okay. Unpause it when you have that written down. What I want to do is take this data set and make this 5-number summary. Okay? So we have to figure out these 5 things. They're always in that order. There's a minimum. There's something called Q1. There's the median. There's something called Q3. And there's a maximum. It's called the 5-number summary because there's literally 5 numbers in it. The easiest ones to find are the minimum and the maximum. The minimum is literally the minimum. What's the minimum? What's the smallest number in this data set? 1. Maximum, what's literally the biggest number? 15. Those ones are easy to find. Next, we're going to find the median. The median is the one in the middle. Now, the nice part about this data set is it's all lined up already. So it's in order. So to find the one in the middle, we're kind of just going to check off side to side, like boom, boom. boom, 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 boom. We're going to work our way towards the middle. Boom, 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 boom. And then we get here, and our middle is actually like right in between those because we have an even number of data points. So our middle is going to be 4.5. It's right in between 4 and 5, 4.5. That's the middle. That's our median. Okay? So we have our minimum over here. We have our maximum over here. We have our median right here. And then Q1 and Q3, they're called Q1 and Q3 because they're like quarter 1 and quarter 3. So what we're really doing is chopping our data up into quarters. We figured out the halfway mark, that's what the median is. But now we're going to take this half and chop that half in half. And we're going to take this half and chop the upper half in half. And when we chop the lower half in half and the upper half in half, we've chopped it up into quarters. Okay? So I'm going to do that for the yellow guy. I'm going to chop it in half by finding the median of the lower half. So I'm going to look at this lower half, the yellow part, and I'm going to find the median. Cross, cross, do-do-do, do-do-do, do-do-do. It's right in between 2 and 3, so it's 2.5. I'm going to do the same thing on the upper half. Boom, 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 boom. It's right in between 6 and 7, so it's 6.5. If you look visually, I have a minimum. Oops, sorry. I have a minimum. I have a maximum. I have a median. I have this thing called Q1, and I have this thing called Q3. And if you look at those purple lines, what I've really done to my data is chopped it up into quarters. I had to use 5 numbers to do that, and that's what that 5-number summary is. Those 5 things kind of chops up the data. All right, let's jump back. So when they make 5-number summaries, they're going to help us make something called a box plot. Okay? Couple of other pieces of vocab. I told you guys before this is a super heavy, vocab heavy unit, so there's a lot of vocab here. Okay? Range. You guys know what range is? It's how spread out the data is. And the way to figure out the range is just to take the maximum and subtract the minimum. Okay? So if you take the maximum, subtract the minimum, you figure out an estimate for how spread out the data is, called range. There's another way to measure how spread out a data is. It's different, again, measuring how spread out data is different than measuring the center. It's measuring how spread out it is. You can have 2 different data sets, I'll show you real quick, that both have the same center. I'll draw 2 histograms here that both have the same center. Watch. Both of them center is right there. What's the difference between these 2? They both have a center at the blue one. They're both symmetrical too. The difference between them is the second one has more spread. It's more spread out. The data is more spread out. Whereas the first one, the data is more packed together. Yeah. So measuring how spread out the data is important. One way you can do that is with range, which is max minus min. Another way you can do that is with something called interquartile range. Okay? IQR. The way to find that is you have this 5-number summary, and you take the Q3 and you subtract the Q1. Okay? Just gives you a different number, but it helps identify how spread out it is. If your IQR is bigger, it's more spread out. If your IQR is smaller, it's more compact. Okay? Last thing, an outlier. It's just a data point that is far away from other data points. It's far away from the rest of the data. Sometimes you collect data and there's kind of one person or one thing that's really different than the other ones. It's called an outlier. Cool. I wanted to make a comment here about the 5-number summary. So when you have your data and you're looking at your numbers and you have your minimum and your Q1 and your median and your Q3 and your maximum. Again, it kind of chops your data up into quarters. Now I want to pause on this for a second. What this allows you to do is if you know Q3, what you know is that 25% of your data is above it and 75% is below it. So if you look at a bunch of test scores and I say, hey, Q3 is an 89%, what that tells you is that a quarter of the people scored better than 89% and 75%, 3/4 of the people scored lower than 89%. If you know the median, you know that half the people scored above and half the people scored below. If you know Q1, you know that 3/4 scored above and 1/4 scored below. That's why this 5-number summary is really helpful, because it lets you chop it up into quarters. And quarters are easy to understand. Okay, you can use percents, but it's easy to think about as quarters, like 3/4 above, 75% above, or 1/4 below, 25% below. Cool? Okay. So when we make this 5-number summary, what we're going to create is a picture from it called a box plot. It's different than a histogram. It's kind of similar, but I like it better. I think it's more useful. Okay? So instead of having a histogram that looks like this, we're going to take the same data and we're going to sometimes make something that looks like this. It's called a box plot. Okay? If you look at the box plot, the general shape of it is like this. It's got a box in the middle, and it's got these 2 little sticks on the end. Sometimes people call it a box and whisker, because they think about it like looking like a cat, I guess. No, I don't know, it looks like a cat. They call those things the whiskers on the end. Not a very good drawer, sad. But depending on how long the whiskers are, or how smashed the boxes are, it tells you about how spread out the data is. So if you have a histogram or some data that's like very skewed to the right, you might have like a longer part on the right or something. We'll talk more about that, but basically if your box plot doesn't look symmetrical, it's because the data is not symmetrical. So if you look at this box plot, it's a little weird. Like this part's a little bigger than that part. That's because the data isn't like even. So if you look at the histogram version of it, it's not even. Okay? You could flip back to this page. I want to take this 5-number summary that we made and make a box plot with it. Okay? So we have this 5-number summary. Here's how you make a box plot. First, if you look at the data, it goes from 1 to 15. So I want to make a little number line. I want to start it at 1, and I want to go up to 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so guys have a number line in the bottom. I'm going to take the 5 numbers and I'm going to put a dot at each one. So I'm going to put a dot at 1, a dot at 2.5, a dot at 4.5, a dot at 6.5, and a dot at 15. Okay. Next, I'm going to make a box between the Q1, I'm sorry, I'll do a different color. Between the Q1 and the Q3. I'm going to make this box. I'm going to draw a line where the median is. And then I'm going to draw the little whiskers on it. And that's a box plot. It's a way to visualize this data. The nice part about a box plot is even if you didn't have this data or the 5-number summary, you could look at this box plot, and once you get good at this, you can really quickly get a bunch of data from it. So I can look at this in 1 second and know, oh, the minimum was 1, the maximum was 15, the median is 4.5, Q1 was 2.5, Q3 was 6.5. I can get this information really quickly from this visualization. I can also see that this is really long. And what that tells me is the data is really spread out over here. There's not a lot of data here because it takes a really long chunk range to get 25% of the data. This is smaller, and it means 25% of the data is in this little chunk. That means there's a lot of data jammed up between 1 and 2.5. And if you look at the data, oh yeah, look at all that data, look at all those numbers between 1 and 2.5. But if you look at between like 6.5 and 15, there's not a lot of data. It's not as much, it's more spread out. Cool? Okay. I need you to be able to make a box plot, and we'll work on that. Cool? I wanted to make a couple of other comments. So when we look at a lot of histograms of real-life data, they're going to be bell-shaped. So that kind of nice symmetrical bell shape is the most common shapes that we're going to see. Okay? So if you kind of just do random stuff, collect random data, a lot of it is bell-shaped. So if you looked at like anything that's kind of like a normal thing, a lot of times the data is going to be bell-shaped. Trying to think of like if you do something like the average, or sorry, if you ask people how tall they are, the heights of people in the US, it's going to be bell-shaped. Why would it be bell-shaped? Well, because the most people are kind of like average height, right? There's a lot of people that are 5'10" that are males, because it's the average height. When you take a height that's really far above or really far below, there's fewer people that are that height. So if you take 6'8", how many males are 6'8"? Not a lot. How many males are 4'10"? Not a lot. That's kind of just natural when you collect data, that the middle is the one where there's the most people. So if you think of a lot of examples of real-world data are bell-shaped. Not all of them, but a lot of things are. We'll talk more about that. So bell-shaped graphs look like this. I just want to draw your attention to two things. First, in the case of bell-shaped, the mean is in the center, and so is the median. So both the mean and the median, those are different things, but both of those are kind of in the center. When you have bell-shaped, it could be a really steep bell, so it could look like this. That's still considered bell-shaped, or it could look like the original blue one. And so between those is how spread out they are. We're going to talk about a third measure of spread besides range and IQR, and it's called standard deviation. It's a fancy measure of how spread out the data is, and it's something that you'll learn more about like in an actual statistics class, but we wanted to kind of introduce you guys to the idea. So we'll talk some more about that, but standard deviation is another way to measure how spread out your data is. Okay. One other thing I wanted to show you. If you want to figure out how spread out the data is, or if you want to figure out what the standard deviation is, how spread out the data is, you can look at the bell curve and you can figure out the point called an inflection point. And what an inflection point is if you think about drawing a bell, and I'm just going to draw the down part, there's a point where you kind of go from drawing it arching like that to switching to have it arching like that. I always say it kind of goes from dome-shaped to bowl-shaped. switches from being dome to bowl, there's a point where that happens. And if you literally draw a bell curve, you kind of feel it happen, like there. That's the point. I'm about to switch from drawing an arch. You kind of switch the pencil in your hand, literally. I'm going to switch on an arch on a U. You can kind of feel it when you draw it, like right there. Now I'm going to draw a U. And that point has important statistical meaning. Called point of inflection, an inflection point, and it tells you how spread out the data is. It tells you a standard deviation. Cool. And we'll talk more about that, but that point is kind of a cool point. It's where you switch from drawing an arch to drawing a bowl. Okay. Just want to introduce you to some ideas. The core skill I need you to be able to take out of this is how to take a data set, figure out this 5-number summary, figure out that 5-number summary, and create a box plot from it. And that's what we're going to do a little bit of practice with, and also answering some questions based on that. All right, thanks for watching, guys.